All right, welcome back everyone to the fisheries portion of day 2 of Wisconsin Water Week. We've heard from some amazing presenters so far this morning. Hopefully you were able to tune into some of those. If you are just now joining us for John Lyons' talk on invasive species, you're in the right place. If this is your first presentation of the morning, make sure to utilize the Q&A feature in the EventMobi platform. That is where we'll be able to monitor those questions as they come in and make sure to vote on, maybe if you're not asking a question, make sure to vote on which question you think is most pertinent, and I will make sure to prioritize those as time allows. John, thank you so much for joining us today. John is a lifelong fish nerd, interested in all things fish, science, management, commerce, catching them, observing them, cooking, and even eating them. John is the curator of fishes at the University of Wisconsin Zoological Museum in Madison, where he has been since 1985. And has spent many, many years as a fisheries research supervisor and scientist for the Wisconsin DNR. And today he's going to be talking a little bit about some of those invasive species we hear so much about in Wisconsin, and what we have learned and how we can address any future threats. So John, thank you so much for sharing your time with us today, and you're more than welcome to take it away from here.
Well, thank you, Luke. Glad to be here, everybody. And as Luke said, I'll be talking about invasive fishes today. And anybody who deals with lakes, anybody who deals with aquatics in Wisconsin, of course, is familiar with invasive species. So we have Eurasian water milfoil, we have zebra mussels, we have rusty crayfish. You're probably familiar with common carp. And so I'll be focusing on the fishes today, not talking about all of them, but emphasizing a few of the better known and better studied species, trying to give a sense of their history, give a sense of what we have dealt with them, and then what we've learned from them and how that can hopefully help us moving forward as we deal with future invasive fishes and invasive species, which are unfortunately inevitable coming into our waters and coming into our landscape. And here is one of the invasive species I'll be looking at, the sea lamprey. A fish parasite in its own native range, but when it invaded the Great Lakes, it turned into a fish predator, and we'll talk more about that in a moment. So what I'm going to cover today, 4 different areas. First, we're going to start with what exactly is an invasive species? How do we define it? And what are they? How many there are? That sort of thing. Then we'll talk briefly about the invasive species in the state, and focusing mainly on 5 different species that are, like I said, really well studied. Little case studies I can do here, give you some background about how they got into the state, what they did once they got here, what the efforts were to control them and deal with them, and what we can learn from that. Then we'll talk about what's on the horizon, who's out there, who's going to, is maybe knocking at the door at the moment, and who might be coming down the pipe eventually. And then, most importantly, what can we do about that? How can we prevent some of the disasters, invasive species disasters that I'll be talking about with the 5 case studies. So first of all, what is an invasive species? And let's talk about the, just a second here. Let's talk about what the definition looks like. So it's a non-native species that becomes established and common enough to have a substantial net negative effect on either native species, ecosystems, or in some cases, human activities. And there's a few things bold in there, and I'm going to deconstruct this, this definition a little bit and talk about it in more detail. So first of all, we're talking about a non-native species established in common. Well, that first of all forces us to talk about what is native and what is not. And so Wisconsin has approximately 150 native species currently or historically present in the state. And these are species that were there. We define native as being here, being established when European settlement first took place. Of course, 12,000 years ago, when most of the state was covered with glaciers, many of those species weren't present, and they have gradually moved into the state over time. But we pick as our starting point, essentially, the early 1800s, as Europeans came into the area and began documenting in a scientific sense what sort of species were present. So 150 native species. In the last 200 years, 17 non-native species have become established. And that's 17 out of many, many, many introductions, dozens and dozens, probably several hundred if you were to count up everything. And so the first message is that most introductions, most invasions aren't successful. And it's only 17 out of, that's probably at most 10% of all the different species that have been introduced. But those 10% can have a huge and disproportionate influence. So, hold on a second. I'm having some technical difficulties here. Give me a second. There we go. So, for example, I'm sort of the person everyone goes to when they catch a weird fish and they don't know what it is. And sometimes these fish are quite weird. They're not just some local species that someone doesn't know how to identify, but they're species like this. Every year, loads of people are dumping their unwanted pets, their unwanted tropical fish, into Wisconsin waters. And some of those, particularly the larger ones, have then maybe caught by anglers or caught by biologists doing surveys, and they're like, what is this? And so here's an example of some of the things that we see. Lots of different non-native species tropical fishes. Now, in a place like Wisconsin, of course, we have pretty harsh winters, and none of these fishes, even if they live for the summer, are going to make it through the winter. So we're fortunate in that regard, in that most of these species are unable to survive. If you live in South Florida, it's a very different matter, where you're in a subtropical area, and when a pet gets released, there's a very good chance it's going to be able to survive. And basically the area around Miami, the canals and the swamps, the Everglades area, are almost overrun with non-native tropical fishes that have been released by hobbyists, unfortunately, and they become established. And so things, for instance, like the Oscar in the center here has become a sort of a sport fish in South Florida. But even though most of those tropical fish are not going to live in Wisconsin, there's always the possibility that someone will have a temperate species, a species that could live here and when it's released, it could in fact become established. So this is really a no-no. And message number one is don't release your unwanted pets. If you can't get rid of them give them to somebody or bring them back to the pet store, please euthanize them. You're doing them no favors releasing them in the local waters, and you may in fact be causing serious harm. The next part is that the species have to actually get common enough and actually cause some sort of net harm to native species, ecosystems, or human activities. The key point here is that even for those species that get introduced and do become established, not all of them are problematic. A classic example here is the goldfish. This is a species that has been being dumped into our waters annually by people. You win a fish at the county fair and you don't know what to do with it, and you don't feel like killing it, so you dump it in the local creek. And so the goldfish are stocked every year all over the state. They're established in a few places, but they really haven't caused problems. So it is true that not all non-native species get common enough, get widespread enough that they be classified as invasive. They don't really seem to do harm. Goldfish in particular are extremely tolerant species. They can live in really stressful and marginal conditions, stagnant ponds, things like that, highly polluted creeks. They also don't do very well with any sort of predator and competitor. So any sort of a healthy ecosystem that they get into, they're quickly eaten or eliminated. And it's really only in these small stagnant ponds and places like that where they become established. But some species then do become established. Some species do become common. Some species do become widespread. And in some cases, they cause harm. And so this is the poll question that I'd like you to answer at some point. You can wait till the end and make your decision, or you can answer it now while I'm talking. But this is the brown trout. And so it checks it seems to check all the boxes for an invasive species. It's non-native. It was brought here in the 1880s, deliberately introduced as a sport fish species. It's extremely common. It's the most widespread trout in Wisconsin inland waters, and it's also common in the Great Lakes. And it has negative effects. Many people aren't aware of this, but it has displaced the native brook trout in many situations. It's a very efficient predator, and it's eliminated many small prey species in many other settings. And so it clearly has had some well-documented and noticeable negative effects. But it also has positive effects. It's an extremely important and extremely valuable and beloved sport fish species that many people, many anglers focus on. For many people, it is the fish to fish for, their favorite fish to catch, and it supports major fisheries, has major economic importance in the state. And that gets to that question of, is it a net positive or a net negative? And so that is the definition. It has to be a net negative, so that the bad has to outweigh the good. And whether that is the case with the brown trout, I guess I'm curious what people here will think. Well, so I said there are about 17 species, non-native species, that have become established in the state. At least 11 of them could be defined as invasive, again, depending on what your point of view is of their positive versus their negatives. I'm not going to talk about all 11. Instead, I'm going to talk about 5 of them in more detail, give you 5 case studies, and use that to illustrate some more general principles about invasive fishes and some of the issues with them and some of the strategies maybe to control them, or at least learn to live with them. And these will be done in chronological order in terms of when they first appeared in the state, starting with the common carp, then the rainbow smelt, then the sea lamprey, the alewife, and finally the most recent of the 5, the round goby. So let's start with the carp. Well, the carp came to Wisconsin from Europe during the late 1800s. And interestingly, in most of Western Europe, common carp is non-native. Its native range is actually the Danube Basin and points east into Asia. And it was actually brought into Western Europe by the Romans about 2,000 years ago. And so, although most people in Europe would consider this a native species, there it actually is not. But it was a species that many European immigrants coming to the United States were quite familiar with and actually quite liked. And so during the late 1800s, when it was brought into Wisconsin, it was heralded as the salvation to the fisheries problems that the state was experiencing at the time. So recall that, you know, European settlement started in the late 1800s and was full bore by in the early 1800s started, it was full bore by the late 1800s. And that was the era when the state was turning to agriculture, when dams were being built, when the pineries of the north were being clear cut, and when fishing was completely unchecked. And so those combination of things had really driven down the native species that were present, and many of the desirable native species were getting harder and harder to catch. And so in the thinking of the time, rather than dealing with some of the environmental impacts or controlling fishing more, the idea was, well, let's bring in another species to replace those that are being reduced. And carp was top of the list. Carp was what everyone wanted to bring in. They were familiar with it from Europe. If you read the scientific literature, much less the popular literature of the time, you find quotes like the one I have here that says, "Sufficient attention has not been paid in the United States to the introduction of the European carp as a food fish. It is quite safe to say that there is no other fish that promises so great a return." And scientific publications, you know, were rhapsodic about all the different types of benefits that carp were going to be. And when carp were first brought over, it was a federal initiative. They were raised in ponds outside Washington, D.C. And every state was clamoring to get their allotment of carp, and they would urge their local representatives, their congressmen, to lobby with the Bureau of Fisheries, who maintained the ponds, to get their quota of carp as soon as possible. And when the carp arrived in the state, they were often loaded on rail cars, tank cars on trains. And as the train went through the landscape, every time it crossed a bridge, they would open a valve on the tank and dump out some carp. And so carp were quickly spread all over Wisconsin, all over most of the eastern half of the United States in those days. So that went on for about 15 years. And then by about 1900, it became clear that carp stocking had been a big mistake. Carp thrived. They did quite well, but they had some habits that weren't very helpful. They fed by uprooting sediment and vegetation on the bottom. They actually ate some vegetation, and that destroyed a lot of the aquatic vegetation that was important habitat for the native species. They, in this process, also muddied the waters. They disturbed spawning of many of the species that use the aquatic plants. And they sort of took over the system. They displaced the native game fishes, and they reached really, really high levels and nuisance levels, in fact. So since 1900, we here in Wisconsin and basically everywhere in the United States and southern Canada have spent all sorts of effort and time and ingenuity trying to eliminate carp. We've built barriers, we've done netting, we've encouraged commercial fishermen to harvest them. We've done all sorts of poisonings where we poison out whole lakes or whole streams, trying to eliminating everything and hope that carp will be eliminated as well and we can start over. The problem is all this has been extremely expensive, time consuming, it's had all sorts of other negative ecological impacts, but hasn't really controlled the carp. There's a few places, a few localized areas where there seems to be reasonable control, but often those are short-term or not complete. And so the lessons we learned from the carp, our first species, is don't believe the hype. Often when a new species is being proposed, the backers of that species will cite all sorts of very reputable information about how wonderful this species is going to be and how it's going to save fisheries or improve fisheries, things like that. But more often than not, those benefits don't pan out, and there are usually often severe and unanticipated consequences as a result. So don't believe the hype. And then a recurring theme for all of these invasive species is, once established, controlling a nuisance species is really hard and it's endless. You can't do it once and then be done with them. You have to continually do it. And it's certainly in 2021 dollars, Wisconsin has spent billions of dollars trying to control the carp with very limited success. Well, our next species is the rainbow smelt. A species, again, you may be familiar with, and you might not actually consider an invasive species, and we'll talk about that in a second. This is a species that's native to the east coast of North America, and it is a very important food fish for larger prey species. So trout and bass, pike, muskie, things like that, they will all eat rainbow smelt, and it's a key part of their diet. It's an important component to their growth. So people here in the Midwest thought, let's bring them here. They'll benefit the growth rates and benefit perhaps the survival of many of our more valuable game fish. So it was brought in as a forage species. Brought in 1916 in a place called Crystal Lake, which is the northwestern part of the Lower Peninsula of Michigan near Traverse City. And it's right next to Lake Michigan, just a mile or so away. And so, not surprisingly, within a few years, they were in Lake Michigan, and by the 30s, they had become abundant all throughout the Great Lakes. Now, in fact, in this case, Smelt actually lived up to their reputation. They were very good forage for many of the native larger predators in the system. Not only that, they were good eating, they were very common, and they proved to be very popular among the people living along the Great Lakes. They were lots of people out going out catching them when they move into the shallows to spawn in the spring. You only have to go back 30 or 40 years in Wisconsin, and there were lots of people catching smelt in the spring, and they still do up in Lake Superior, where they remain fairly common. You could buy them in the stores, you could go to smelt fries on Friday night, things like that. So you're saying, well, what's the problem here? Why are they considered an invasive species? Well, it is this idea of net positive versus negative, their net benefit. And it turns out it wasn't really appreciated at the time, and it was only sort of retrospectively, that smelt proved to be very, very efficient competitors and predators on many of the larval ciscos and whitefishes, and some other species like perch and walleye that had been the mainstay of the sport fisheries out in the Great Lakes. And at the time, people didn't realize the impact of the smelt. The studies hadn't been done. But in fact, their occurrence and their rise to incredible densities was associated with the decline of many of the important commercial and recreational native species in the lake. And those species declined sharply as smelt became more and more common. Well, smelt populations in the Great Lakes, not only, they were common, but they fluctuated wildly. The populations tended to bounce all over the map. You have really good years where smelt were everywhere, and then for no clear reason, the next year smelt would be quite scarce. And this went on for about 20 or 30 years, and then in about the 90s, early 90s in Lake Michigan, they just declined sharply and nearly disappeared, and the reasons for that aren't clear. So they remain up in Lake Superior, where they were never nearly as abundant as they were in Lake Michigan. But the problem was during that same time period, they were mistakenly moved into several northern inland lakes. And again, I think people thought, hey, it's a great fish out here to eat. Let's put it in some of our inland lakes. It'll help those situations. But in fact, it didn't really help those situations, and it's hurt native cisco populations, it's hurt native walleye, it's probably hurt native perch populations. And now we spend a lot of time in many northern Wisconsin lakes trying to figure out how to control or eliminate the smelt. So a couple of lessons from this species. Smelt populations varied tremendously over time, even before they declined. So many invasives are characterized by great instability in their numbers and in their population dynamics. Often when they first get into a system, they get up to a really, really high abundance, and then they kind of overrun their food base. They crash down to a lower level, and then they fluctuate wildly going forward. So they're often not nearly as stable in abundance as native species. And as I've talked about, there are some, just like the brown trout, there are some strong positives and strong negatives. And really invasive, and what you consider invasive, may be in the eye of the beholder. As a fish ecologist interested in all species, I would say their effects have been net negative, and that they have caused more harm than benefit. But again, if you love to catch smelt, if you love to eat smelt, go to those old smelt fries that they used to hold, maybe you're going to feel differently. So whether something's invasive isn't always clear cut. Now we'll turn to the next one in the sequence, the sea lamprey. Now this is another species native to the east coast of North America as well as in Europe. And it's what's called an anadromous species. It spends most of its adult life out in the ocean in its native range, and then comes into tributary streams and rivers to spawn, and then spend its juvenile period as larvae in the freshwater areas. Now, in its native habitat, it's a parasite on really large organisms. It's a blood parasite. It attaches kind of like a leech, bores a little hole and sucks blood. And it's the same sort of lifestyle as a leech would have. And so you can see in this picture in the upper left, it often attacks whales. And so on a whale, you can see two circled here, two sea lampreys out in the ocean. On a whale, a sea lamprey is equivalent to, you or I getting a leech on us when we're walking in the water. It's not desirable. You might think it's kind of gross, but it's not life-threatening. It's more of an annoyance than anything else. And so you'd have these sea lampreys focusing on big whales, on big sharks, on larger fishes, and not, I wouldn't say they help the fish, but they don't really cause serious harm. Well, they were blocked from getting into the Great Lakes by Niagara Falls, shown here on the right. So historically, they've never had access to the Great Lakes from the ocean. And so they weren't a problem. But beginning in the 1840s, to permit shipping, people built a canal to bypass, it's called the Welling Canal, and it's in Ontario, and this is a picture of it. And it's to bypass Niagara Falls and allow ships to move via a series of locks from Lake Erie down into Lake Ontario. And eventually, over time, it took about 100 years, but sea lampreys used this canal essentially to gain access to the Great Lakes. And surprisingly, even though they're an anadromous species that normally goes to salt water as an adult, they were able to spend their whole life in fresh water. Now, the difference here in the Great Lakes between the oceans, of course, is the Great Lakes doesn't have fish nearly as big as out in the ocean. There are no whales. There are no 20-foot-long sharks, for example. The biggest fish, if you saw Mike Donofrio's talk, there were sturgeon. But by that point, when the sea lamprey arrived, the bigger sturgeon were extremely scarce. And so the main fish left, the biggest fish left in this system were the large predators, particularly the lake trout, to a lesser extent like whitefish, burbot, fish that would get 2 or 3 feet long as an adult. And so if you have a 2 or 3 foot long lamprey attacking a 2 or 3 foot long trout, that's a much different impact than a 2 or 3 foot long lamprey attacking a 30-foot long sperm whale. Again, picture yourself, you're wading in a stream, and instead of a 2-inch leech attaching to your ankle, a 3-foot leech attaches to your ankle. That could be serious. And in fact, it was serious. And so their parasitic lifestyle of sea lampreys, when they moved into this new area of the Great Lakes, turned into a predatory lifestyle. They basically were killing their hosts because they were taking too much blood out of them. And they quickly devastated all the large fish in the system. They hit every large fish, sucked enough blood, killed them, and then started moving down to smaller fish. And a lot of populations of a lot of species were in free fall. And in fact, lake trout disappeared from Lake Huron and Lake Michigan and barely was hanging on in Lake Superior for a variety of reasons, but sea lamprey was one of the main components of that decline. Fortunately, through lots of effort and lots of research, lots of money, we've come up with systems to control sea lamprey numbers, not to eliminate them, but to control them. Again, remember, they need to go into these tributary streams to spawn, and their young have to spend their early years in these tributary streams. Well, there's been a whole series of barriers, dams, electric barriers, things like that built to prevent their migration. And then about 50 years ago, a species-specific toxicant called TFM is the shorthand for a long, complicated chemical formula that selectively killed lampreys was introduced and has been used ever since then to keep lamprey numbers down. And you can see on the right side of this slide, you can see some pictures of the Fish and Wildlife Service doing lamprey control in some Great Lakes tributaries. That's good news. It keeps the lamprey numbers low and has allowed many populations of native fishes and introduced fishes in the Great Lakes to rebound. But it costs millions of dollars annually to do this. And you can see the shot on the left, if you don't treat them, the sea lampreys come right back. And this is lampreys caught at a barrier system on the Brule River up in northern Wisconsin, which again, if the treatments are done every few years when the populations get large enough, because it's just too expensive and too much labor to treat every stream every year. So the lampreys are under control, but they're not eliminated. And so the lessons from the lampreys are, first of all, invasions can take a long time to materialize. In the case of the sea lamprey, they had access to the upper Great Lakes for nearly 100 years before they really established and started to cause problems. So as long as there is access, a threat from invasive species remains. So even if they haven't invaded yet, they haven't established large numbers, that doesn't mean that isn't going to happen at some point in the future. In some cases, unlike for the carp, control can be possible, but it's, in this case and inevitably, it's going to be extremely complicated and extremely expensive. It's much, much better to just avoid the whole issue and keep the lampreys, keep the invasive species from invading the system in the first place. Now we'll switch to alewife. This is another East Coast fish, very similar to the life anadromous species like the sea lamprey, in that it lives in salt water as an adult and then moves into tributary streams to spawn, and those tributary streams serve as a nursery area for the larvae and the young. In its native range in the East Coast, it's a food fish. It's actually important as a food fish, and it's in decline there. So there's a lot of efforts to actually restore alewife runs and bring alewife and other what are called river herrings back to areas where they've been eliminated by pollution and dams and things like that. Just like the sea lamprey, it used the Welling Canal to bypass the Niagara Falls, and it arrived in the Great Lakes about 15 years after the sea lamprey. So the sea lamprey arrived maybe in the early 40s. The alewife arrived in the mid-50s. Now, by the time the alewife arrived, the Great Lakes were a different place than when the sea lamprey arrived only 15 years earlier. A combination of overfishing and predation by the sea lampreys had basically devastated all of the larger predators like lake trout and burbot and things that would normally have eaten any alewife that had come in. As we heard earlier, the smelt had also reduced the abundance of the cisco and the whitefish, which were the main planktivorous species in the system. And alewife is a planktivore, it eats midwater plankton. So all the alewife competitors were down as well. So you had no predators, no competitors in the system in the 50s. And so alewife, in their perspective, this was a paradise. And so they came into a predator-free, competitor-free environment, and their populations went through the roof. Estimates were that in the early 60s, something like 80 to 90% of the total fish biomass in the Great Lakes were made up of alewifes, just alewifes. And this is a fish that only gets 5-6 inches long. So we were talking about probably trillions of alewifes. I mean, numbers like the US national debt, some things you can't really comprehend very well. Trillions of alewifes, not billions, trillions. And so they reached these incredible numbers. They overran their food resource, as often is the case, and started having these horrible die-offs. And they would clog the harbors during the early 60s, mid-60s, with dead alewife that had died often from the stress of spawning. They were in poor condition and they spawned, and the stress of spawning, they died. And so these are scenes, this is a scene from Chicago. I mean, the whole harbor is just carpeted with alewifes, and the beaches were carpeted. Things stunk. No one wanted to go to the Great Lakes. It was just it made the shoreline a very unpleasant, unappealing place. And so it seemed to be like the final nail in the coffin of the Great Lakes. The top predators were all gone. Sea lampreys were running amok. The commercial species like whitefish and cisco had crashed. Many of the other species like perch and walleye, which were primarily bay and harbor species, were way, way down. Sturgeon, as Mike talked about, were way down. And the lake instead was full of non-native sea lampreys, non-native smelt, and particularly non-native alewifes. And so in the mid-60s, there was a bold and almost desperate experiment by folks in Michigan where they brought in Pacific salmon to feed on the alewifes. And originally, no one thought that these salmon would actually control the alewives. They just said, well, here's this huge food resource. Let's bring in these salmon and see how they do. And in fact, they took off. they did really well creating this major fishery for Chinook salmon, coho salmon, brown trout, rainbow trout, and areas that had been economically depressed within a few years were booming because anglers were coming from literally across the country to fish for this incredible new salmon fishery, a salmon and trout fishery out in the Great Lakes. And the states in the area, including Wisconsin, ramped up hatchery production to produce these salmon. Millions and millions were stocked every year. Populations of the salmon and trout got high. And over time, they began to bring the alewife population under control. At the same time, other invasive species were coming in. You had things like cladophora, you had things like zebra mussels that we'll talk about in a second that were just changing the nature of the ecosystem in ways that were less favorable to the alewife. And so over time, you went from this nuisance species in the trillions in the 60s to now in the 2000s, there's real concern that alewife might disappear. This has already essentially happened in Lake Huron. The alewife population has crashed. And when the alewife population crashed, the salmon populations, the salmon fisheries that everyone loves so much crashed with them because these salmon are really dependent on the alewife. They don't really feed on much else. They just eat alewives. Alewives are still doing okay in Lake Michigan, but there's really a lot of concern about that too much stocking, too high a density of salmon predators is going to cause that alewife population to crash as well. And so alewife has gone from this hated, despised species to this species that now many anglers think is precious. And there's even been proposals to stock alewives now to get their numbers back up. So the lessons are that successful invasions, particularly in the case of alewife, often take place when a system's already stressed and the fish community is already degraded and there's this huge open niche for the invasive to come in, and that's absolutely what the alewife did. They had an opening and they really exploited it. The other lesson is that perceptions of invasives can really change from, in the case of alewife, it's despised nuisance everyone hated in the 60s and 70s, to this really highly valued prey species that now people are trying to preserve. Because again, it's gone from being a negative to a net positive, at least in some people's opinions. Finally, we'll talk about our last species, which is the round goby. This is a bottom-dwelling species that's a native of southwestern Asia, the Caspian and the Black Sea area. It's found mainly there in brackish water and in tributaries. This is a species that was really unlikely and unexpected. No one saw this one coming. And it was brought to the Great Lakes in the ballast water of ocean-going ships. And again, the Welling Canal played a key role because the canal was constantly being upgraded, bigger and bigger ships could go through. And by the 80s and 90s, the whole waterway system, including the St. Lawrence and the Welling Canal, made it very easy from ships to steam directly from the Mediterranean Sea, the Black Sea, all the way to the Great Lakes in the matter of a couple of weeks. And when they got to the Great Lakes, they would often exchange their ballast water coming in from more buoyant salt water into less buoyant fresh water, and they'd have to adjust their balance, and they'd discharge water and take on water. And somehow or other, larvae or eggs of round goby were there. They got into the system in the Great Lakes through that mechanism. They became established. They, again, took advantage, like the alewife, of an ecosystem that was under stress. And it was in the middle of a shift because of another invasive species, zebra mussels, from a system that was primarily midwater productivity, phytoplankton and zooplankton, to more benthic productivity, zebra and quagga mussels, cladophora, algae, things like that. The ground goby, being a bottom fish, was moving into an environment just to its liking, lots of food, lots of hiding places, and it thrived. And soon it had spread all over the Great Lakes, up all the tributaries as far as it could go, basically, up to the first dam or waterfall, and dominated the bottom, and it displaced the whole group of native fishes, things like sculpins, things like darters, some benthic minnows. And so a diverse group of 5 or 6 different species that you normally see, say, in the harbor area or nearshore area of the Great Lakes has now been replaced by a monoculture of extremely abundant round gobies. This is a small fish. It doesn't get more than normally about 6-7 inches. It doesn't really have any sport fish potential. And so at this point, it's all negative. So the lessons learned for the goby are some of the invasives we're looking at are really species we didn't expect. They're kind of off the radar, and there are all sorts of new novel ways to get there. In the past, it was either they took advantage of an existing canal or connection, or somebody dumped them out of a bucket. Now they're coming in and, you know, as a contaminant in ballast water. And the modern transportation networks that have now made the arrival of almost any non-native species possible. So we have to consider a much larger pool of invasives. So what are the 5 takeaways from the 5 species? Non-native fish that look good on paper can be trouble. They usually don't live up to their hype. Prevention is always much better and always cheaper than control. Control is possible sometimes, but not others. Invasions can take a long time to develop, as we saw for both sea lamprey and alewife, so we need constant vigilance. Altered environments, things that are stressed, have been degraded, often facilitate invasions. And the whole concept of globalization in a smaller world and greater transportation networks means that there are many more potential invasives out there that could invade Wisconsin. So who's on the horizon? Who's next? Well, the one everyone hears about, and the one that is probably the most looming threat at the moment, are the so-called Asian carp. And you may have seen videos like this where carp are leaping madly about boats going through them in the water. In fact, there's 4 species of Asian carp, and only one of them, the silver carp, is the leaper. But there's the bighead carp, the silver carp. They both look similar, but only the silver carp is the one that leaps. The grass carp and the black carp, which look a little bit more like our common carp. So all 4 are often referred to as Asian carp, even though they're in many ways very different species. And they're all potential invasives. They were brought over to the United States from their native range in Eastern Asia back in the 70s, and for a variety of reasons. The grass carp for vegetation control, the silver carp and the bighead carp for control of algae in sewage treatment and aquaculture ponds, the black carp for control of invasive snails in aquaculture facilities. Once they got into these facilities, they soon escaped. They got into the Mississippi River, and they've been spreading ever since. So why are they problems? Well, the bighead carp and the silver carp are planktivores. They eat plankton, but they eat really, really tiny plankton, and as well as phytoplankton, not just zooplankton. And they eat the tiny plankton that most larval native fish and even some adult native fish need to survive. So they're potentially huge competitors. They're very efficient planktivores, and the worry is that they're going to outcompete a lot of the native fish, particularly the larval fish. The silver carp is also this leaper we've heard, and it's a human health threat to boaters. People have gotten severely injured being hit by a leaping silver carp while motoring. Grass carp eat aquatic plants, but they're too efficient for their own good, and they can eliminate aquatic plants in a system. Again, and many native species require those native plants. And black carp are very efficient eating freshwater mussels, and the upper Mississippi system and the Mississippi system in general, is the richest freshwater mussel area in the world. And there are many rare and endangered mussel species. And there's a worry that this invasive could eliminate or at least reduce their populations. So what do we do? Well, they're knocking on the doorstep. They're almost here already. Small numbers of grass carp, bighead carp, and silver carp have been seen in the upper Mississippi and some of its larger tributaries since the 90s. Not black carp yet, but they're not too far south in Illinois. So far, the good news is they haven't been able to reproduce successfully. They're just seen as, I guess you'd call them strays, although they're getting more and more common. But as we saw with the sea lamprey and the alewife, sometimes it may take a long time for things to be established. And everyone's kind of holding their breath in the Mississippi, because you can't really block the Mississippi to keep them from moving up from places further south in Illinois and Missouri and Kentucky, places like that, where they're well established and extremely common. And fish are constantly moving north, and the fear is eventually they're going to hit some critical mass and they're going to become established. But it hasn't happened yet, so keep our fingers crossed. The other issue is they're moving up the Illinois River in central Illinois, and years ago, the Illinois River was connected to Lake Michigan through what's called the Chicago area waterway system. And that's for shipping, basically. It allows barges and small craft from the Illinois River, which goes into the Mississippi, to move into Lake Michigan and vice versa. And so this is primarily for commerce. And once upon a time, the river, this waterway system was so polluted from sewage and industrial waste from Chicago that no fish could cross between. But now that's been cleaned up, and now all of a sudden there's a potential straight shot for Asian carp to get into the Great Lakes through Chicago. And so there's been a lot of concern that that's going to be a way in which they get into the Great Lakes, and they're going to devastate an extremely valuable but already stressed out fishery and ecosystem in the Great Lakes. So what do we do? Well, in the Mississippi, barriers are impractical. What we can do is maintain healthy ecosystems and balanced fish communities to prevent the carp populations from exploding. Where they've exploded further south in the Mississippi system, those systems are a lot more modified and not in as good a shape as the upper Mississippi around in Wisconsin, Minnesota, northern Iowa. Not to say that the Mississippi in this area is pristine, but it's in better shape than it is further south in Illinois and Missouri. And so if we can keep a healthy ecosystem there, maybe we can keep the carp out, but that remains to be seen. In Chicago, the issue is blocking their advance. And there's been some major efforts by the Army Corps of Engineers to build electric barriers there that would prevent carp. And these are pretty expensive, elaborate, sophisticated arrangements. The question is, are they actually going to work? And it remains to be seen. And some people have called for the complete closure of this system, breaking that connection between the Mississippi Basin and the Great Lakes Basin. But is that economically or politically feasible at this point? No. So who's next? Well, as the ground goby proved to us, it's really hard to say. Carp are on the doorstep, but any day, some weird species from across the other side of the world could end up in our waters. And it's really hard to know who's going to be next. Scientists make lists of the most likely species and the species most likely to survive. And those are useful, but as a number of our species have taught us, sometimes the species you don't really predict to show up or don't really predict to thrive actually do. So what can we do? Well, we can be vigilant. We keep an eye out. We can educate people. Don't release your pets. Don't release unwanted fish. Be careful. Clean your boat off. All those sorts of things. Do the best we can to prevent access of invasive species, both intentional. We don't want people deliberately stocking things, but accidental releases as well. Maintain healthy ecosystems. That's the key. The better the ecosystem is, the more resilient it's going to be to most invasive species, not just fish, but all sorts of invasives. And then monitor, keep an eye out. And in some cases, if you catch an invasion early enough and respond strongly enough, you might be able to eliminate it before it gets a toll. So that's another strategy. So let's just sum up. So first of all, we talked about what invasives were, non-native, common, and then this whole idea of net negative impacts. And as we saw with some species, whether it's net negative or net positive might be in the eye of the beholder. Most introductions fail, and that's good news. The bad news is a few of those that succeed can be devastating. And it's really hard to predict which species will be trouble. Often species are promoted and they look like on paper they're going to be great and helpful, and then they turn out just the opposite. So it's hard to know sometimes who's going to be the most problematic invasive. And related to that, the whole concept of what constitutes an invasive species can be subjective. It depends on your point of view and what you value most. And it can change over time. So alewife went from being despised to loved. And things like brown trout, depends who you talk to, whether it's an invasive species or a real benefit to our waters. prevention is always better than control. So if we can keep the invasives out, or if they get here, if we can quickly respond and eliminate them, that's always going to be better, cheaper, and simpler than some sort of control. And finally, I can't emphasize this enough, keep our ecosystems healthy. The better shape our ecosystems is in, the more balance it is between predators and potential competitors and things like that, the more likely it is to be able to resist invasion. And we saw that with alewife. We saw that with gobies, that these altered environments really promoted the establishment of these species, which we will, in the case of gobies, are unlikely to ever be rid of. So that's what I have, and I'm happy to answer questions, and I hope you enjoyed the talk.
Fantastic. Thank you so much, John. I really appreciate it. This is definitely a complex and expensive problem that's going to really be at the forefront of managing our waterways for many years to come. We have quite a few amazing questions coming through, so thank you for everyone that submitted a question. And we'll just try to get to as many as we can. The first one is specifically about Great Lakes management. The Great Lakes are very highly managed systems at this point, especially in terms of fish stocking. What would happen if we kind of stopped stocking fish and we let the food web revert? Would we, is that something that people are talking about? Would those introduced sport fish populations where the native species survive? Would the invasive species come back? Kind of one of those hypothetical questions.
Well, it's a great question, and it's not really hypothetical because that's exactly what's been going on in Lake Huron. So the alewife population collapsed there, and then the introduced salmon populations essentially collapsed there. That, depending on your point of view, is a good thing or a bad thing, because on the one hand, there does seem to have been a resurgence of native species in Lake Huron. Lake trout, lake whitefish, various Cisco species seem to be doing better and are coming back, and Lake Huron looks more like it used to 200 years ago than it did 20 or 30 years ago. But that came with a huge economic cost that many people, many communities have been dependent on salmon fishing and all the economic benefits it brought. And it was, devastating to many of those communities, many of the people who were in that business. So it was not intentional, but it sort of served as an unplanned experiment. In Lake Michigan, right now, the feeling is we don't want to do that experiment again. But even if we were to stop stocking, in some of the Lake Michigan tributaries on the Michigan side, some of the salmon species have now become well enough established that they are thriving on their own without stocking, and there is supplemental stocking on top of that. But even if we were to stop stocking in Lake Michigan, it's unclear whether the salmon would disappear because they've become established there.
Excellent, thank you. This next question, maybe you can take us on a bit of a history lesson. We talked a lot about these non-natives and how they get established, especially in Wisconsin, but what are the most common ways that native species get established in nude water bodies? And specifically, how did those native species originally populate Wisconsin lakes after the last glaciation?
Yeah, really interesting. When the glaciers were at their maximum, maybe a quarter of the state was unglaciated. That's the driftless area. And that area would have been very harsh aquatic environment, tundra-like. And so probably a couple of species may have hung on there. But essentially, 148 of the 150 species arrived in the last 10, 12,000 years. And they moved up river systems, and they used natural connections. The landscape we have now looks very different than the landscape 10,000 years ago. And many lakes that are isolated now were connected. There were much larger lakes, and so what are a series of small isolated lakes now was once upon a time a much bigger lake that was connected to other lakes. And so it was basically a colonization process. They took advantage of natural river and stream connections or flood connections. And as they moved from the south where they had survived glaciation, they spread, and you can trace that. Certain species weren't able to get into a certain watershed before, for example, a waterfall barrier, natural barrier evolved, and that species is lacking from there now. And in other areas, they were able to get there, and they spread widely. So that's a whole field of biology called zoogeography, which looks at how fish get where they get naturally. And on top of that, many native species have been moved by people. Certainly game fish species, but lots of other species sort of accidentally or incidentally. So the modern distribution of even our native species is pretty different now than it was, say, 200 years ago.
Excellent, thank you. This next question kind of gets at people's perceptions of certain invasive species. In particular, this question is about round gobies. This viewer mentions that anglers in some areas are talking about how round gobies are resulting in larger bass in the Great Lakes, and so improving fishing. So they see them as beneficial, and they mentioned that gobies are having minimal impact. Maybe you could offer your opinion or thoughts on the relation to anglers and thinking that a certain invasive might be beneficial in an area, and how to kind of respond to that.
Yeah, I mean, certainly if you get up in the Door County area, there's a perception that because gobies are so abundant there now, smallmouth bass in particular are growing to larger sizes. And that hasn't been completely established, but it's plausible. It's wouldn't be completely surprising. The bass are taking advantage of this resource that wasn't there before. But in the process, they've eliminated, the gobies have eliminated 5 or 6 other bottom-dwelling native species that used to be there. And and those are fish that bass used to eat as well. And so bass have always done well off Door County. It's good habitat for them. And yes, the gobies are abundant now, so they're growing maybe a little bit better, but they never grew poorly. And the issue is when the food resource for a species is a single species, it's just one species, that's a lot less stable of a food base than when it's based on 5 or 6 or 7 species. And we saw with the smelt, for example, that numbers would fluctuate all over the place. And that's kind of what most invasive species do. Their numbers vary quite a bit. And so if you have one species and it varies quite a bit, well, that's all the bass have to eat, so they're going to be affected. Whereas if you have 6 or 7 species, they're unlikely to all vary in sync. And so one is up, one is down, one gets abundant, another gets less abundant. And so you have a much more stable food base. And so right now the goby food base is very high, but if there are a couple of bad years and the goby population were to crash, the bass would not have a plan B. So that's why we prefer a more diverse native assemblage.
Yeah, it sounds a lot like that net negative is really important there.
Yeah, and it's what your perception is.
Yeah. So we got 3 minutes. I'm gonna get to as many as you can. I don't think we're gonna get to all of them, so I'm sorry to those viewers that we didn't quite get to touch base on. Goldfish, aren't they a type of carp? And why don't they have the same negative impacts that common carp have?
Yeah, they are in the carp family, so to speak. They're not that closely related to the common or Asian carp. They just are not a good competitor. The only place they can do well is places where there's really nothing else. Anytime there's any kind of a predator or a competitor with them, they just don't compete well. Their specialty is dealing with really extreme environmental conditions. So they'll live in say a stormwater pond that's been constructed and just drains all this nasty stormwater up the street. Those systems will be too stagnant and polluted for most native species, but goldfish will thrive there because they can tolerate it. And then as soon as conditions get a little better in that pond and native species get in, the goldfish disappear.
Excellent. Sea lampreys, why don't they have the same negative impacts on the Pacific salmon and prevent them from becoming established? Why is it so specific to certain species?
Well, they do. They attack all the trout, and they attack lake trout. The issue was the Pacific salmon weren't introduced until sea lamprey had been partially brought under control. And if sea lamprey had been running amok the way they had been about 10 years before the Pacific salmon had been introduced, then the Pacific salmon wouldn't have made it. They were able to make it because the sea lampreys were controlled. And as soon as, if there's ever a cut in funding or the sea lamprey have a particularly good year, you see wounding and mortality on the Pacific salmon as well as on the native lake trout. So they're an impact on all the fish.
All right, I think we'll squeeze one more in because I think this is an important one. And I think it's kind of a common perception when people hear about these problems and challenges, especially in terms of common carp. But this person asks, why isn't there more research and effort being put forth to control common carp? You know, why aren't we using them for food for pets? You know, insert X idea to manage these. How would you respond to that kind of perception?
Well, first of all, we spent inordinate amount of time and money, 100 years or more, studying and trying to figure out how to control carp. And we've tried sort of everything under the sun. I mean, they're a problem in Australia, and they just had a big trial in Australia where they introduced a carp-specific disease to try to control the carp, and with high hopes. And it didn't work because, yeah, it killed a bunch of carp initially, but all the carp that survived then had immunity and weren't killed by it anymore. And so it was a temporary fix. And so those sorts of things, we're still looking for the silver bullet. As far as food, yeah, they are used for food, and they're caught and transported and used for food, but they're not a high quality, high value fish. And there isn't that much demand for them for pets or for human consumption. And so there isn't enough of a commercial fishery to really bring under control in most places. There just isn't enough demand.
Absolutely. And I'll make a quick plug. The book Overrun by Andrew Reeves talks about Asian carp and goes into a lot of detail about. So if anyone's interested in learning more about Asian carp and common carp, I recommend that. John, thank you so much for joining us. Really appreciate your time and sharing your knowledge with us. We didn't get to the poll. I think I saw that 56% said yes.
That it is
59% that yes, it is a native. So a few people not sure, but shows how tricky it is to.
Well, I would try. I didn't think of this, but I wish I had asked as a secondary question, how many of you are trout anglers? Just to see how that split. Yeah, because many, I'm a trout angler, and I know lots of them, and they love brown trout.
Absolutely. Again, thank you, John, to everyone that joined us this morning. Thank you for tuning in to the fisheries section. I encourage everyone to check out some other amazing presentations that are going on this week, even this afternoon. Make sure to, if you haven't registered for tomorrow's session, I encourage you to do that. There's just going to be a lot of amazing presentations throughout the week. And I think we're very fortunate to have the UW Extension team putting something on like this. It's been really enlightening to hear from some amazing speakers today. So thank you to all our speakers. Thank you to our host, Tony Johnson, behind the scenes here today, helping with Zoom. Thank you to the whole UW Extension team. And thank you, obviously, for the guests for joining us today. So thank you very much. And hopefully we'll see some of you later in the week.